hello, everybody. Thanks for coming to this late afternoon talk. I'm Megan Wolf. I'm an open source maintainer at Defense Unicorns. I work on a project called Lula. I'm here to tell you a little bit about that project. I'm going to talk first about the state of the world. The impetus for the talk is looking at Lula in particular with a focus on evaluating admission controllers in your system, your Kubernetes system. So we're going to kind of intro that. What's the problem that we're trying to solve there? What is Lula? I'm going to go through a quick demo and then wrap it up. So what is the technology we're talking about? Most people are probably running Kubernetes systems at this conference, and as such, will have many admission controllers in their systems processing workflows. If you need the nice Kubernetes definition of what an admission controller is, basically it's just a piece of code that intercepts information on the way to the Q API and does something to it, can validate it. So like, yep, that's good. No, that's bad. Mutate it, change it up. What are these in the wild? I'm sure a lot of people have interacted with these. Some inject sidecars into pods. Some will accept or deny requests based on policies that you already have in your cluster, how you've defined or how you want your system to behave. There are operators that do things like inject certificates into your pods. We have operators that will, validate that something has like a certain CPU posture or something before deploying. So very security-heavy operations, and generally something that's not completely obvious as the user occasionally. So who's caring? These guys from AI-generated min coder and security engineer there. So people are developing software for systems, developing applications. If I'm an application developer putting something in a system, I need to understand the implications of what that system is going to be doing to my application, particularly if I'm developing another type of controller that's going into a system. I definitely really care if there's going to be sort of an interesting behavioral result of that. The hooded figure on the right there is security engineer. A security engineer really cares about the system, cares about defining what the system should be doing and then understanding what the system is actually doing. So they care a lot about the behavior of these controllers, care about the behavior of the system, and how to basically characterize and prove that behavior. All right, so I kind of hit the problems a little bit, but how are you discovering and proving what is happening, particularly with admission controllers in a complex system, repeatably and with evidence? So visibility is hard. There's these things in your system doing stuff. You think you know what they're doing, but how do you trace that lineage? And once you say, okay, this thing is happening, how are you actually providing evidence that behavior is occurring every time you give an input? How can I verify that given the same input repeatedly, the same output is occurring? And then systems drift. There are human beings that do things. Software gets updated. System this morning is not the same as the system this afternoon. So the assertion is that current testing and evaluation processes for this are very ad hoc. Not that they don't exist, but they're pretty ad hoc. So what the proposed solution here is kind of a framework that helps intend to bridge that gap between my expected system and my in reality system. So how can I, again, prove and measure repeatedly in a robust framework the system behavior? So Lula is a CLI tool that basically provides a framework for collecting evidence and evaluating that evidence. It's a free and open source project. We use an open source data format called OSCAL, Open Secure Control Assessment Language, I think. But it's managed by NIST, government organization. So no, ideally, like vendor lock and proprietary data format of the inputs and outputs of the tool there. So at a high level, is providing this framework. At the more granular level, you don't have to read this big YAML. It's mostly there just for descriptive purposes. But what this actually looks like is you're creating the framework, or you're creating the definition of your system in OSCAL in something called like a component definition, and it's saying, this is my system, and these are the things I'm asserting my system will do. My system will will prevent unauthorized access or something like that as a definition. How do you prove that? The proof is sort of in what information is collected and evaluated by the Lula validation. So it's kind of broken into two layers, so to speak. So there's the domain portion where we're saying this is the system or the evidence to be collected. So in this case, we have support for Kubernetes, so we can go out and grab all of the Kubernetes pods in the cluster that you're pointing it at. We also have support for just kind of like generic file types to pull in that data. And then the provider is, okay, I've got this input data. How are you actually evaluating what that data is saying and giving sort of the yay, nay, pass, fail on the control that you're linking that against. And so we support OPA, Rego, and Kyberno policy declarations there. And so the output of that, again, is this assessment results format. It's an OSCAL open source language there to actually consolidate that information and ideally provide it back to a party of interest. Okay. This is kind of just a visual on the continuous evaluation part. Really just kind of trying to hammer home the repeatable aspect of it, and the repeatable and, again, systematic proof of that. So we have, system at time one, and we've defined it by this OSCAL and accompanying Lula validations to basically assert the system behaves a certain way. We run our evaluation. Okay, great, we have the information. Okay, system at time two. The system is different. It's changed state. We still have the same definitions that encapsulate that system. We have a second evaluation, and so Lula is really helping us identify those important changes between that might impact your compliance and your assertions and understanding about the behavior of your system. Okay, that was pretty much the slide material. So I was gonna pull up the terminal and we'll see what happens there. But really just kind of wanted to show the tool and show it kind of in a situation where we're evaluating UDS cluster, UDS core cluster, and a Pepper admission controller functionality. Basically, the cluster is a secure runtime cluster for hosting Kubernetes applications. Not here to talk about that. You can come by our booth if you want to hear more about that one. And we've got the admission controller that basically handles the policy, accountability, and the networking kind of stuff running in that cluster. So just let's pull up a couple scenarios there. Oh, and I have the files up on GitHub if anybody wants to follow along, because there's some validation data there. Hopefully that's big enough. All right. That's what I want. Okay, so what I pulled up here, so I mentioned Lula is a CLI tool. We have a fairly new-ish terminal user interface just to kind of make the interaction with OSCAL slightly less painful. OSCAL is like a very bulky machine readable language, and machine readable is great, but it's not always very human readable. So we kind of tried to make like a Lula flavor interface to the data. So I'll just kind of walk through hopefully what I explained in the slides thus far. So we have this component definition. It's super basic. The one component we're looking at this UDS operator, and you'll see pepper interchanged here. They're a little different, but for demo purposes, we're gonna say they're interchangeable. We're making this assertion that this emission controller is implementing policies that prevent unauthorized changes from occurring within the system. Well, that's our assertion. What is our proof, or how do we prove that assertion is true? So we have these Lula validations down here. We're doing kind of a basic health check. Does this thing feel closed? And then a couple kind of boring validations to check that all pods are dropping capabilities and check that all pods require non-root user. So if I pull open the non-root user one, you can kind of see I showed the actual schema for the validation. This is a slightly beautified version of the Lula validation just for readability, to kind of show like we're breaking it out into the domain. Up here, we're pulling all of these pods from our cluster. And down here at the bottom is our rego policy that is going to just take that data, which basically comes in as JSON, take that data and run it through a policy and check that we are not running as user 0 and we're require non-root false, or like all the checks that would need to go through to basically prove that. So let's see. I've run, oh no. Tab problems. I ran that through the first time, and we can look at the results. So this is the situation where the system has changed. So I have my results that I've run from earlier today. I've got my system, I've got my evaluation, and oh yay, it is satisfying the control. We have effectively run these validations where we're proving through pulling all these pods and examining them and running through this policy that the system is behaving in the way that we expect it to behave. So we have the read version there, and the other kind of flavor of this, which is more, I would say, interesting towards the behavioral component, is what I denoted here as right, but probably somebody smarter could come up with a better word than that. But essentially, we're actually doing like, if I inject the cluster with some data, is it responding in the way I expect? So now we're saying, okay, we're gonna actually try to add a couple pods that are running as root user. Like, we just want to validate that this controller is doing what it's doing. Like, I've read the current state. The current state is that nothing is running as root. Cool. If I do something new, is it still behaving that way? How do I know that my state hasn't changed in a way that would change that behavior? So this is just saying, like, I'm just gonna inject a couple of these pods. I expect them all to be rejected by that validation policy. So yeah, I ran that one earlier, right? Okay, that's satisfied too. So this is the state where we've now changed the state of the cluster. It's a little bit later in the day. Bob came in. He was messing around. I don't know what he did. Let's check how things are going. We're gonna rerun our validations. We've got all of the data in there. This was the read version again, just checking the current state. We're checking that everything in there is, healthy, dropping all capabilities, not requiring root user. Okay, let's do the comparison to the old, and it's all unchanged. The findings are unchanged. The observations down here, which reflect the validations, are all unchanged. So if we, let's see, go back and do the right version. Again, all the same information, didn't have to change anything here. We're going to execute this, and we've got a little warning, executable validations, we're actually doing something to modify the cluster. We don't just want to kind of run this without a heads up. This one kind of takes a second because it's gonna come over here. So we can just watch. There's kind of a lot going on in this cluster, so it just takes a few minutes to reconcile. But we expect that the two drop-all capabilities pods were mutated properly, and the require non-root user should not be created. But spoiler alert, the cluster state changed. It's going to be created. So we'll just give this guy a second. Drink some water. I wish I had some music. Did anybody do anything fun this weekend? Nope? Okay. We actually have feedback on the CLI. It's great. It gives you a little spinner, and it tells you which validations are running, but the terminal user interface is much less sophisticated, so it just says validating. So we just get to sit and kind of stare at this, but to try to fill the gap and reiterate the points. Essentially, what we're trying to prove is that we can draw conclusions by interrogating our cluster repeatedly, or interrogating our system really, external to the system, and get those proof. Yes, got some results back. Perfect. So you saw the read case didn't change because the actual static information in the system didn't change, but because we were able to probe the behavior, we were able to see that the system became more permissible. And so we've got a state here where we can compare our old system to our new afternoon system, and things are now not satisfied. They're falling out of compliance. One more super quick one, because I think I have the time for it. The other moderately interesting one that we support here is actually evaluating custom resource deployment behavior. So in this case, we're saying, okay, we have this custom resource. We are expecting these resulting resources to be created from this thing, essentially. So this is like a package. We expect a bunch of network policies to be created. So based on how I specified this, we're expecting this output. And so we can run, this one goes a lot faster, another validate to basically say, put that thing in the cluster, wait for it to be ready, pull the data back, should be satisfied. We'll see if I am a liar. You make me a liar. So there's a funny instance with this custom resource, which I'm not going to get into, but this is a great evaluation to show that I expected this behavior and I saw something different. But in a nutshell, that's repeatable proof using some of these Lula validations. I think that's really all I wanted to show there. So I have no idea how I'm doing on time. Admission controllers create complex system behaviors. I saw that. Lula can be a great framework for, again, allowing you to characterize your system, building the proof to repeatedly evaluate it, pulling back that proof, and possibly identifying edge cases or emergent behavior. If you were continuing to rerun this, we have kind of a case for doing this in CI in particular, but really any system that you were wanting to understand over time. I think obviously those are very basic examples. This gets, I think, potentially much more exciting in larger complex systems where there's a lot of things moving around, and we want these better feedback loops over the life cycle. And that's it. Any questions? Oh, yes.
So in the demo, you had a couple tabs that piqued my interest.
Yeah.
And I am a C compliance person. So
Oh.
I saw OAM,
Yes.
milestone, and system security plan. So were you able to export your assessment findings from Lula into a module to be able to track for remediation? Or
So right now, Lula kind of only supports inputs of component definition, outputs of assessment results. We have on the roadmap to support the system security plan and the POAMs and delivering those, but our core tenet, I guess, is that we're going to keep everything in OSCAL. So eventually, we will support POAM data as a result, like including these assessments in that information and probably other juicy information, but we're still building that out.
then follow-up question, with the assessment piece, are you able to import potentially, if you get the right data set, import applicable controls from like 800.171, 853, CIS, et cetera, or is that just something?
Can we import, sorry, my best presenter, I forgot the rules I need to repeat. Can we import applicable controls from 853? Yes. Yes, we have a Lula generate command that generates, it generates profiles now and generates the component definition using like the selected catalog of interest, so your catalog of choice, and it just creates, so it's kind of, I talked about the validation portion, I didn't really talk all about Lula, but a lot of our focus has been generating the OSCAL artifacts in and of themselves. There's the validation framework, but just having the component definition and the kind of those associated artifacts. Yeah. Anything else? Nope. Okay, I think that's probably it. Thank you all.